section 5.6 on compound interest. You should have completed page 1 in class with a partner or a small group today. If you were absent, then please look at the answer key attached on the assignment sheet. So if you need to pause the video, go ahead and do so. You're going to write down all of these formulas. So we're going to talk about compound interest if it's being compounded at a certain number of times per year, or we're going to do compound interest when it's compounded continuously. So if it's being compounded a certain amount of times per year, either daily, weekly, monthly, quarterly, semi-annually, we're going to use A equals P times 1 plus R over N to the NT power. A is your ending account balance. P is your initial account balance. R is your rate, but you have to convert it to a decimal, so don't leave it as a percent. N is the number of compounds per year, and T is the time in years. Now, if you don't know how many days, weeks, or months there are in the year, then I've written that at the bottom. So there's 365 days per year, 52 weeks in a year, 12 months in a year. Quarterly, think of 4 quarters in a dollar. There's 4 quarters in a year. And semi-annually is like half. So every half a year is semi-annual. So there are 2 of those per year. Now, most situations are going to follow the continuous compounding, at least in real life, because things that grow or decay are not going to just do it at the end of every day or at the end of every week or at the end of every quarter. It's going to always be growing or decaying. So that uses the formula A equals P times E to the RT. E is the number E, so approximately 2.718. The A, P, R, and T are the same as the compound interest formula. And E, as a reminder, is the base rate for all continually growing processes. All right, we're going to do 3 example problems using these formulas to check our understanding. So first thing we're going to do is we're going to look at estimates of the number in millions of U.S. households with digital televisions. It's given by the equation D equals 30.92 times 1.012 to the T power, and T represents the number of years after 2000. Is the number of households with digital televisions increasing or decreasing between 2003 and 2007? Well, if we wanted to, we could substitute the number 3 in the equation and substitute the number 7 into the equation and see what we get. Does it increase or decrease? But better yet, just pay attention to the 1.012. That tells us that it's 1 plus 0.012. And 1 is what you start with. Because you're adding, that means that you are increasing by 1.2% per year. So is it increasing or decreasing? It is increasing. In part B, we've also sort of answered this question. What does the 1.012 represent? And that is the increase in the number of digital televisions. So let's add a little bit of context to this answer. The number of U.S. households with digital TVs is increasing by 1.2% per year. All right, the other part of the question says, what does the 30.92 represent? That's your starting value. So in this scenario, in context, it would tell you that in the year 2000, which is when it started, there were 30.92. Now, this is in millions. So million U.S. households with digital TVs. All right, the last part of this question says use the model to estimate the number of U.S. households with digital televisions in 2015. So pay attention to 2015. We're actually only going to substitute in T to be 15, not 2015, because it's the number of years since 2000. So you're going to take your equation, D equals 30.92 times 1.012 to the 15th power. And when you type that into your calculator, you should get 36.9783 million U.S. households. On the day of a child's birth, a deposit of $25,000 is made in a trust fund that pays 8.75% interest. Determine the balance in this account on the child's 25th birthday if interest is compounded weekly, monthly, and continuously. So depending on the rate of compounding, we're going to use a different formula. So if we are going to do it by a certain number of times per year, we're going to use the A equals our initial amount, which is 25,000, times 1 plus our rate, which is 0.0875, divided by the number of compounds per year. So let's start with weekly. Weekly is 52 times per year, and we're going to raise that to the number of years times the time. We're going to raise that to n times t, which is the number of compounds per year, times 25, because that's the number of years we're going to keep the money in the account. All right, for monthly, we're going to have essentially the same formula, except the number of compounds per year is going to change to 12. So instead of 52, we're going to put 12. We're going to change this 52 to a 12 also, but everything else stays the same. Finally, we have our continuous compounding, which means we're going to use our PERT equation. So that is going to be A equals 25,000 times E to the rate, which is 0.0875 times 25 years. All right, once you type these equations into your calculator, for weekly, you should get $222,413.32. We should round to 2 decimal places for money because we only have pennies, so we only need 2 decimal places. For the monthly one, we have $221,061.10. Notice this is a little bit less than the weekly one because weekly had more frequent compounding, so you got a little bit more interest. And then the last one is going to be the biggest value because that is continually compounding the entire year, never taking any rest from the compounding. So an infinite number of times per year. So that's going to give us $222,822.57. All right, our last question is the number of bacteria in a certain population increases according to a continuous exponential growth model at a rate of 8.1% per hour. There are 1,800 bacteria at t equals 0. So when it starts, you have 1,800, and this is your rate, which we will change to a decimal. Write an equation that gives the number of bacteria after t hours. Notice that they are focusing on hours as opposed to years as the frequency of our compounding, and so all of these units are in hours as opposed to years. All right, so we're going to use the PERT equation. So we do A equals our starting amount, which is 1,800, times E to the 0.081, because we move our decimal place 2 spaces to the left, times the number of hours, which we don't know yet, so that'll be raised to the 0.081t power. All right, now it says find the number of bacteria in the population after 6 hours, so we just need to let t equal 6 and see what we get. So 1,800 e to the 0.081 times 6. Make sure that both of these values are in your exponent. And if you type this in your calculator, you're going to get 2,926.44 bacteria, but I would assume that individual pieces of bacteria should be rounded to the nearest whole number. All right, if you have any questions on these check your understanding problems, please ask your teacher.